final lesson in the unit. I don't know if this is part of 3.9 or 3.8 if I just tack it on there. I don't know. I'm not figuring it out. I'm just recording this. So watch it whenever you will watch it in the future, which is your presence. Which is your presence. Your present. This is the past for you, but it's the present for me. Presence. Anyway, here we go. We're graphing polynomials from factors. This is not an exact science. I'm not saying you need to have the most perfect graph in the world. We're talking about general shape here. So here, I have a polynomial that's been busted into its 4 factors, right? This is like saying I have 3 times 2 times 4 times 6. What I really have given you here is 12 times 24. That's a big number. Let's not do something that big, okay? Why would I do that? Let's do like this. Okay, that's better. That's 24. Here's saying I give you 24, graph it. You're just breaking it into its pieces. So these are the factors. These are the pieces that all multiplied together will make the polynomial. Don't know if that made sense. Anyway, how we do this is we take each of these things, each factor individually, and we will set it equal to 0 and we will solve because each of these factors represents a 0. X minus 3 equals 0. X minus 2 equals 0. X plus 4, 0. And then lastly, x plus 1 equals 0. And then we solve, okay? I hope I'm not breaking the bank when I say that x equals 3 for this one, x equals 2, x equals -4, and then x equals -1. Okay, we have our x's, which means we will place them on the x-axis here. I see that I have a positive 3. 1, 2, 3. I see that I have a positive 2. I see that I have a -4, so to the left. 1, 2, 3. That's where -4 is. And then a -1. Okay, I have placed my zeros. And now, I should have something like spaghetti looking. It's gonna look like a sea monster. Okay, it's gonna go up, it's gonna go down, it's gonna be wavy. If you graph this in your calculator, it will be much more precise. It will be much more, but I'm not interested in that. I'm interested in the general shape of this. So here's what I'll do. I'm always gonna start down, right? Do I start down? Do I need to check? Do I start up? No, I'm gonna start down. All right, we're gonna go, and we're just gonna weave through these dots. Okay, pretty sure we always start down. We're gonna weave just through there. It could be up here. It could be real quick down there. Okay, your graph is your own. Your spaghetti monster is your own. We are just approximating what this looks like. So let's go into our calculator and let's actually take a quick look to see if this is correct or if I have just wasted minutes of your time, precious minutes that are in the future for me, but again are in the present for you. It's a weird form of time travel that we're kind of doing here. So let's see, -3, -2, +4, +1. Here, in our calculator, we can type in exactly what we saw. It was x minus, what? Oh crap, I forgot like immediately, just immediately forgot. -3, -2. And then it was x plus 4, x plus 1. Graph. Well, that doesn't do a lot for me now, does it? So it does start up. It starts up. Interesting. So I did have it wrong. I did have it wrong, but I had the right idea. See, we're learning. Okay, still got my zeros. I did that part right. 1, 2, 3, 4 over here, and then 3 and 2. I hope you didn't write this in pen because I'm not redoing this video. So instead of starting from down, we're gonna start from up. Boom, like that. That is the general shape of this thing. Again, you can be a lot more precise if you really wanted to. Can I zoom somewhere in the middle? Something that's not weird like this? If I go to this Symbolab website, fantastic website by the way, and I type x plus 2, or is it minus 2? 2, x minus 3, Now this is going to graph it. And yeah, it's hard to see where that's coming from, but it does bend. Okay, so we have this loop that exists down here, and we're gonna have probably, if I dig for long enough, a loop that goes down there. I'm not gonna do that. This video is terrible. This is the worst video I've ever made, but guess what? We're gonna keep it. Okay, we're gonna keep it exactly how it is. That's the answer. Move on. Here, I have three things. I'm gonna set these each equal to 0, 1 at a time. X plus 6 equals 0. X minus 1 equals 0. 3x plus 2 equals 0. Okay, x equals -6, x equals 1, x equals, subtract 2, divide 3, x equals -2 over 3. All right, so on my dots here, I got -6, 1, 2, 3, 4, 5, 6, all the way over here. I've got +1 right there. And then I have -2 over 3. Again, general shape, not an exact science. It's not quite -1, but it's like almost there. So maybe it lives there. Okay. So now, this one, confidently, he says, is gonna look like this. Coming back to me. Confidently, he says it looks like that. What is the difference? Why does this one look like a sea monster? So I imagine like this is Loch Ness, right? That's the hump, I don't know, okay. And then this one is so like W and wavy and up. It has to do with the amount of factors that you have. The amount of things, curves you have in a function are proportional to the degree of the function. That is a lot of ways to say, if I have an original linear function where y equals x, we know that on a graph, this is a very straight line. It looks like that. It's a linear function. Suddenly, I add a higher degree, y equals x squared. Now my degree is 2, my degree is up. But that introduces one curve in my function. I have one bend, okay? If I continue going, y equals x3, well this time, I'm not gonna have, here I have no bends, here I have one bend, here I'm gonna have 2 bends, because the amount of bends, the amount of curves or changes in direction is 1 less than the degree of my function. So I'll have 1, 2 bends. It's gonna look like that, okay? So the amount of bends is 1 less. Here my degree was 4. So I'm gonna have 3 bends. First bend, second bend, third bend, and then onward. And it will always point up if you have an even number. You will always have both ends pointing up if you have an even number. If you have an odd number of zeros, 1, 2, 3, 3 is odd, you will start down and you will go up. So with these shortcuts in mind, speed run, set each of these equal to 0. I'm gonna have x equals 3, I'm gonna have x equals -2, I'm gonna have x equals -4. That's gonna be here, here, and here. I have 3, so that's gonna start down, and it's gonna look like that. Over here, how many x's? Because x's are zeros. How many x's? I see 3 bubbles, but I see 4 x's. This one right here. So let's figure out the ones that we know. This is going to be x equals -5, x equals -1, x equals 2. Well, what did we do here? We set these equal to 0, and then we solved, right? X plus 5 equals 0, and then we solved to figure out it's this. I'm going to take that, I'm going to set it equal to 0. X equals 0. Hey, that's a number, I can graph that. So I have a 0 right there. At 2, bam. At -1, bam. At -5, that's like 1, 2, 3, 4, 5. Okay. This is an even number of zeros because I see 1, 2, 3, 4 factors. So we're gonna have that W looking thing. Maybe this one goes way down here and is tiny and then goes back up in the bam. Okay, there we go.